Have you been considering converting your Ender 5 or Ender 5 Plus into a direct drive 3D printer? Well, MicroSwiss may just have the easiest solution for this, but why would you want to convert your printer into a direct drive printer, and does the MicroSwiss solution really live up to the hype? Well, that's what I'm going to be taking a look at right here today on Kersey Fabrications. Let's go. So let's start off this video by first talking about what is direct drive and what makes it different from what you may be used to on like the Ender 5 or the Ender 5 Plus, which is a Bowden setup. Well, a Bowden setup, which you probably are familiar with, is where your extruder sits on usually some sort of fixed point of the printer, and then it runs a tube which has your filament in it to your hot end. And then basically the extrusion of the printer has to go through that tube to get out of the nozzle. Well, a direct drive solution is basically where you take the extruder motor, which was fixed back here somewhere on the printer, and you've moved it up to right next to the hot end somewhere. And what that is hopefully going to do is give you cleaner retractions. It's going to make your filament pass shorter, and it's just overall going to give you a better, cleaner extrusion for your 3D printing. But as with most things, there is a potential downside from switching from Bowden to direct drive. When your printer is moving around, it is obviously carrying around the mass of whatever is on your gantry. So for a Bowden setup, this is usually just the hot end with that Bowden tube going to your extruder motor. Now, if you're going to go direct drive, you're obviously going to be moving that extruder motor to your gantry, which is going to add additional weight to the movement of that system, potentially creating either a slower printing experience or potentially adding some ring or noise to your 3D prints. So that's going to be the trade-off that you're going to have to make if you are thinking direct drive. So these are going to be things I'm going to be taking a look at in this video with all of these various test prints. Now that we've talked a little bit about Bowden versus direct drive, let's take a look specifically at the MicroSwiss solution. So what is MicroSwiss offering in their all-in-one kit? Well, first of all, as I mentioned, it is all-in-one. This box contains everything you're going to need to convert this printer or a regular Ender 5 to a direct drive 3D printer. It has all your wiring, it has all of your hardware, screws, everything you're going to need to do the conversion. In fact, this version of the kit even comes with their all-metal hot end, so that you can actually start printing with higher temp filaments. And the reason I really love the all-metal hot end, because it also helps switching out nozzles between prints, because you don't have to worry about that PTFE tube butting really tight up against that nozzle in order to create a really nice seal. And along with that all-in-the-box, all-in-one solution that they're offering here, they're also offering a solution that does not require firmware modification in any way. So this means that the only modification you're going to have to do is with settings, and this can be done with a G-code file that you just put in here and run, or it can be done by connecting over the USB to modify your steps per millimeter, but that's all you're going to have to do. It's a pretty easy thing to do considering what you're actually doing to your 3D printer here. And the other thing I wanted to mention after working with so many of MicroSwiss's components is you're really getting a well-engineered product here, particularly in terms of their fit and finish of the product. And we're about to see that here as we go through the unboxing of this product. So let's go ahead, segue over to the unboxing. Let's take a look at what comes in this package, and we'll see how it all goes together later on in this video. Now let's take a quick look at what comes in the box. Now this is the MicroSwiss direct drive extruder, specifically for the Ender 5, 5 Plus. Again, if you're looking for an Ender 3, they make a different model. And this is made in the USA because they actually machine these parts at their shop here in the United States. And this is the one that comes with the hot end. As you can see here, it is a dual gear drive. They are hardened tool steel gears, sharp precision cut teeth, adjustable filament grip, and a plug-and-play kit, which I'm actually looking forward to because that should mean that the install goes pretty easily. And that's pretty much it for the box. Let's see what comes inside. So first of all, as you can see, this is the really, really nice machined aluminum mount that everything is going to attach to. This is what's going to replace that existing part that's on your printer. As you can see here, this is where the hot end goes. Again, nice machined raised piece here. This is your filament path, which means your extruder is going to be right in this area here. As you can see on the back, they've actually built in the mounting for your 3 wheels that attach to your X gantry. And of course, this is where your belts attach. Now, you may think that this is not smooth because you can actually see the texture there, but this is mirrored finish, as you can see kind of with the way the light reflects. This is a beautiful machined part, and they've really outdone themselves on this custom piece of fabrication here. Next up, we have, this is the Micro Swiss hot end, the all metal hot end that I've reviewed plenty of times on the channel before. You can click around and see some of those reviews. Anyway, this is one of my absolute favorite parts on my Ender 5 Plus just because it works so well. Next up, we have our heat block. Again, pretty standard. We have a new nozzle that it comes with. Now this is a brass 0.4 millimeter nozzle that is nickel coated. That's where the color comes from. So this is not a hardened tool still. If you want one of those, you'll have to get a new one. Comes with a nice card here that links directly to where you can find these step-by-step instructions on their website. We have a bag that includes our tools and our little clamps that will go on our hose connectors for our filament path. Again, we got some extra parts here. These are the screws that are actually going to connect our hot end to our new mount. We have more screws and a short piece of filament pre-cut for that path to make it a really nice path, particularly for those flexible filaments. We have, again, these are more parts of the extruder. We have the extruder arm. This is the part, you know, you're familiar with this on your Ender 5 Pluses, on your Ender 3s. This is the part that you squeeze to release the filament, or to load the filament for that matter. We have a nice extension cable. This is going to take our extruder motor from where it is on the chassis now all the way to the hot end, which is where we're moving it to. We have a nice silicone sock. Now this piece here, this is our final piece other than some cable ties which are in here. Now this piece right here, this is just going to take the place of where we were mounting the motor so that we can actually run a hose from here to basically make a nice filament path for our filament so that it doesn't get caught up on anything. Now, if you were going to run it a different way, you wouldn't need this, but on the Ender 5 Plus, for example, we are still using the filament runout sensor, so we will need this. And again, that's it. Let's get to the installation. So obviously in this review, we need to take a look at the weight difference between the stock setup and the direct drive setup from Micro Swiss so that we have an idea of how much more weight we're actually talking about carrying around. Are we talking about 50% more weight? Are we talking about 2 times the weight? Exactly what are we looking at? So what I've done is I've separated the shared components of the 2 setups, pulled those out, and we're only going to be taking a look at the components that are specific to each setup. So first we're going to take a look at the Bowden setup, and then we're going to be taking a look at the direct drive setup. So here we are. We have our metal plate. This is where everything gets mounted to with our stock setup. We have our hot end, and we have our bag of screws and nuts and spacers. And that brings us to 81 grams for the stock setup. This is the lightest we're going to be doing. And obviously this doesn't represent the full weight of what we're carrying around because we still have the fans and BL Touch, things like that. But this is the starting weight. So let's take a look at the direct drive setup. So with the direct drive setup, again, we have our bag of screws, nuts, miscellaneous parts. We have our aluminum plate. We have our all metal hot end. And of course, we're already up to 126 grams or so, and we haven't added our stepper. So let's add our stepper to all of this and see what we're at. So this is our NEMA 17 stepper, the same one that comes with the machine, and now we're up over 400 grams for the total weight that we're going to be carrying around with this setup. So that is over 4 times the weight going with the direct drive setup as opposed to going with the stock setup. That is quite a bit more than even I expected. And let's just say for the sake of argument, if we wanted to reduce the weight by trading this out for a pancake stepper, I've got a pancake stepper right here. This is an E3D 0.9 degree stepper, something like we'd use for this. And this brings us to still just under 300 grams at 294, which is still 3 times the weight as we would be carrying around with the Bowden setup. So we're not talking about a little bit of weight here, and we're going to have to see how this translates into our test prints, and is all of this weight worth it? What are we gaining? So normally this is where I would put the installation of the direct drive, but I've decided that for this video, let me try to put it at the end where it can be easily found if you are looking for it in the future. And if this is not something that you've come here to see, but you want to just see the review, you can watch that at this time and maybe catch that later. So we can go ahead into the calibration for the direct drive on my setup. So first of all, I went ahead and calibrated the steps per millimeter for this unit on the Ender 5 Plus. I found that on my printer, I got 139 steps per millimeter, gave a good solid extrusion time after time. After that, I went on to calibrate flow for my particular filament, and for the nozzle that I'm running on here, I got somewhere around the 89% flow, which I find is really common, at least on my Ender 5s. And finally, I went and I did a stringing test, and on the stringing test, what I'm looking for is getting the retraction just right. Now, the recommended retraction on this is, I believe, about 1.5 millimeters at 35 millimeters per second. I found that my retraction was 2 millimeters at 35 millimeters per second, gave a good clean print with minimal stringing. At that point, I was all set up and I was ready for these test prints. So starting out on my test prints, I wanted to start with a very basic test to just do a simple comparison to make sure that the new setup was working like I expected it to. So I started out with one of these very basic test prints that has a lot of different tests on it. It has some dimensionality tests, it has stringing tests, overhang tests, and some bridging tests all built into one print, as well as taking a look at the text quality on such a small print. What I found when comparing the before and the after was that the results are very comparable. I can pick out differences between the two prints, but again, it's not anything major. While, for example, I like the text a little bit better on the before, the overhangs look a little bit better on the after, and some of these minor differences could just come down to a slight flow change, maybe a slight step per millimeter off, something like that, because even when you calibrate, something can be slightly different between the two. But again, if I didn't have these two next to each other, I wouldn't have a problem with either one of these. They look very, very good. Next up, I wanted to run a test print for an issue we knew we would have, particularly on a direct drive extruder, and that is printing at higher speeds. Couldn't find a test print that was exactly like what I wanted, so I went ahead and designed my own. You'll notice that this test print is fairly large, and that's so that we could get up to speed as we went up to the higher millimeters per second. Now, this test print has straightaways, it has curves, it has overhangs, just to test as we went up to different speeds. You'll notice on the front we have both embossed and debossed numbers that show the speed as we're going up, and I will make this test print available. As you'll notice on the bottom, you have 40 millimeters per second all the way up to 120 millimeters per second, and what we're looking for are artifacts that come from going too fast with a particular print head, and you're going to particularly see those as we change directions on these embossed and debossed numbers. So this is with the default Bowden tube setup. What you'll notice is that at the slower speeds on here, we get almost no artifact from speed. We get no ghosting, and as we move up, it's almost a linear progression to slightly more ghosting. And until you get up to probably 80, 90, 100, you're really not getting too much on here, and it looks really, really good. I would even say that even up to 120, depending on what you're printing, it's probably an acceptable amount. And as we switch on these curves, I really don't get any ringing or ghosting either. It looks really good. In fact, the only real differences I see as we hit about the 100 millimeters per second mark, I do get a little change in the sheen of the filament, and that probably could be corrected by raising the temperature of the filament a bit. But overall, it looks really, really good. Now moving over to the test that I ran with the direct drive, what we start seeing here is that as we go up, we start seeing real issues probably around the 60 or 70 mark, where we start getting the extruder just not being able to keep up with the change of direction, and we start getting some really nasty ringing that actually is a texture that you can feel on the print. And again, you start seeing it around the 60-70 mark. By the time you're about 90, it is noticeable. It's really noticeable on both the embossed and the debossed. You're also going to see it as you change direction sharply, and you do see that same discoloration in the filament that we were seeing, of course, on the Bowden setup. But overall, I would definitely say you're going to have to make some changes in your acceleration and jerk in order to compensate. Now, I did want to make sure, this was with my 2mm that I found, and I wanted to make sure that the retraction setting didn't have any impact on the quality of this print. So I went ahead and did a 1mm retraction to see if there were any issues. And on here, I did not find that the retraction made any noticeable difference in the print. They both look just about the same. Now, in the installation of this kit, I did note that the adapter here that we use to run our Bowden tube to our hot end was a bit off for this printer. And so I wanted to make sure that we weren't dragging at all, that also did not have any sort of impact. So I found a new adapter that someone had already modified and put on Thingiverse, again, link in the description, to make sure that that also didn't have any impact on the quality of the print. And again, did we get any change here? I wouldn't say so. I would say that it's pretty much exactly the same. So again, we're not dragging filament. Filament's being extruded cleanly. This is just from carrying around that mass and really just not being able to accelerate or change direction quick enough. I did have a little issue here where I had to do the 120mm layer separately for this one, but that actually was a problem by my own doing, not a printer problem. Next up, I want to do the same exact test, but on the flexible TPU filaments. Now, why did I want to do this? Well, basically what I wanted to see, could a stock Ender 5 Plus, number one, could it print flexibles at all? And number two, what speeds could it print flexibles at before it really had problems? And so I ran the same test print to see at what speeds could we print. Now this is with the Sane Smart blue TPU, and as you can see here, we only got up to 50, and the second we went to 60mm per second, it was completely unable to catch up, and we ended up having a clog or a tangle at our extruder. Now looking at the quality is definitely not impressive at the 40 or 50mm. It actually did pretty good on the sides where it didn't have to change direction or do anything. The curve looked really good. Even the overhangs looked pretty good. But on the one where it had to change direction, we got noise all over the place on this TPU. Now, let's take a look at how the direct drive did on TPU. Now, on this one at the slower speeds, particularly at 40, 50, it looks really, really clean, even where it had to change direction. Now, as we go up, first of all, you'll notice there is a full tower here. So it was able to print TPU even up to 120mm per second, but with degraded quality. You'll notice the noise goes up starting at 60 and just keeps going up from there. Again, TPU is typically suggested to print slowly. This was just a test to find out what the direct drive was capable of. And again, adjust your acceleration, your jerk, so that even if you want to print quickly, the TPU has time to keep up as you're ramping up the speed. But I was really impressed. This is a full speed tower all the way up to 120mm per second printing TPU. And let's be honest, the Sane Smart TPU is a really flexible filament, and this did really well. Moving on from there, let's go ahead and do a model with flexible filament and see how it looks. So since I was able to print flexible with the stock extruder on here, I went ahead and printed a little nom-nom model. And this was printed at 40 millimeters per second because that looked the best. And I have to say, this looks really, really good. It feels good. It doesn't come apart. And the infill feels like it's probably not quite all there. But again, the outside looks good. This is an acceptable TPU print, particularly on a printer that really wasn't designed to print flexibles. So moving on to the direct drive Omnom, this one feels a lot more solid. And again, this one's printed at 40 millimeters per second also. It feels a lot more solid. The infill, you can tell, is all there. The exterior of it is darker, meaning that there is more filament being laid down. We're probably just getting overall better extrusion. If I didn't have them side by side, I probably couldn't tell that either one of them was particularly better than the other, but you can definitely feel a difference. Also of interest, I was like, well, okay, if we can print at a faster speed, what would a model look like at a faster speed? And so I went ahead and printed an Omnom at 100 millimeters per second. And right here, again, it feels actually a little bit more solid than the one on the Bowden setup, but it definitely does not have the firmness that you have on the slower model, and the surface finish is honestly pretty atrocious on it. So again, TPU not really meant for high speeds, but if you want to be able to print at high speeds and you're willing to do a lot more tuning and tweaking, you might be able to print the flexibles at higher speeds with this direct drive extruder. But with default settings, I wouldn't count on your quality. Now for my final test print, I wanted to throw something at it, not just a model, because I think most models, particularly if they're solid, particularly if it's not a very complex model, you're not really going to see a big difference from the direct drive to the Bowden. So I wanted to throw something really challenging at it. So how about a model that we have to extrude and retract a lot? And that's where I came up with the Eiffel Tower. Now I've tried to keep my hands off of this as much as possible to preserve the integrity of the stringing and everything else on this model, because obviously there's a lot. This is a lot of retractions. This is a 22-hour print, printing at 50 millimeters per second on this. Obviously you're never getting up to that speed given the amount of starts and stops, but it's an important number just so that you know what my target was. Now one thing I can say, with the Bowden setup, while the stringing is horrible, while each little detail on this Eiffel Tower does not look particularly great, it is all here. It did extrude every little detail, even if they don't look terrific. And I think this is 200% size on this model, by the way. But everything looks pretty good. Just a lot of stringing. But even the very small handrails, all of the details in each of the overhangs just looks phenomenal, even with the Bowden setup. Again, it's all here. Can the direct drive improve on the Bowden setup Eiffel Tower? That's what I was hoping. I actually gave it a model that I thought it might be able to really knock out of the park. Now this first one is with the 2 millimeter retraction, the one that I figured was my best settings. And I have to say, it was not as good. Overall, there are pieces of the railing that are missing. The stringing is somewhat improved, but not a ton. You know, maybe marginally, but it's very difficult to see inside some of these small areas. Stringing slightly improved, let's say. But with the errors in the print, it definitely does not look as good. The extrusions on the very small pieces might look slightly better. But again, it really didn't knock it out of the park the way I thought it would, and I was really hoping it would. Now, to show that we're printing direct drive and we have much shorter extrusions, I did time these. Again, this was just short of 23 hours, and the This one was 16 hours and 20 minutes. Again, if you're only retracting about 2 millimeters, you're going to have a much faster print. And just to find out, again, I wanted to make sure that my 2 millimeter retraction wasn't just too far. I went ahead and I printed one with a 1 millimeter retraction, and this is definitely worse than the 2 millimeter. The handrails are almost completely decimated on here, both inside and out. The stringing is not particularly any better, but definitely not as good a quality of print. And to verify that the retraction was lower, it printed in 15 hours and 28 minutes. So again, not really getting much higher quality prints, at least here, on a print that I really thought it would knock out of the park. Now I want to talk just a little bit about why I didn't try other prints on the direct drive extruder, and I think the best way for me to cover that is by talking about this print that I did for Halloween. Now this print right here is a haunted house. I think it has a better name. I'll put it up here on the screen. And I found this on My Mini Factory. This was a huge hit last Halloween, and I went ahead and downloaded it for this Halloween for my house. And I really wanted this to be a showcase piece. So this was a fully tuned stock Ender 5 Plus. And again, the only thing I'd done to this printer was change out for a silent board and did all of my tuning. And this print is one of the nicest prints I have ever pulled off a printer. It has beautiful overhangs. It has beautiful extrusion. And if you look at all of the details here that I'm going to show you, you'll notice that every detail of this model is here. It has high pointed tips, even this very top one, which is probably less than a millimeter across, is gorgeous. This particular one here, where it goes thin and then goes wide again, was able to do that without breaking it. So I really thought that given you can take a stock Ender 5 Plus and get a print that's this clean and this nice, you're definitely not going to be able to improve on this with the direct drive. You're just trying to keep up. So Editor Kris here. After that somewhat of a rant on Bowden versus direct drive, I decided I did want to go ahead and throw in a couple of regular test prints here just to make sure that my assumptions were correct. So I went ahead and 3D printed two prints that I know pretty well. I've got my Batman bust here, and I have a Captain America bust. And I just wanted to make sure, do these live up to expectations? Do these look like what I've seen on the Ender 5 for so long from the Bowden setup? And for the Batman, the only thing I really see is a bit of layer lines, and this is most likely just due to the fact that I probably need to adjust my flow a little bit. But overall, the extrusion does seem pretty consistent. I don't notice any flaws with this print other than that. So I think there's a little bit of tuning that needs to be done to get this one just right. And looking at the Captain America bust, again, everything looks really good. Same sort of flow inconsistency that I really was not seeing on any of these prints. And so I really don't think it is the direct drive. I think it's just my settings. Now, I'll find more out about this as I spend some more time with this direct drive. I do have a lot of time. I'm going to leave it on here. So anyway, Editor Kris signing off. Thanks for listening to my rant there. Now, one last thing I did. I understand that my results are just my results. I'm not the be-all to end-all to any particular mod, particularly for the way I install it, for the way I tune it, tweak it, the models I throw at it. So I did turn to my patrons and I asked them, have you installed a direct drive and what do you think of it, particularly this direct drive? Now, what I heard from my Patreon supporters is that they love this direct drive mod and that they found that their prints were improved with it. Now, again, we don't have side-by-side comparisons from them, but I did want to get other people's opinions. They loved it, so I wanted to throw that at you, that to them, this was an improved mod for their printer. Now, what I want to do is give you my final opinion on the Micro Swiss direct drive and let you know, would I buy this myself? So I want to split the conclusion of this video up into two parts. Number one, let's talk about direct drive in general. Number two, let's talk about the Micro Swiss kit specifically. So what are my thoughts after finally converting what was originally a Bowden printer into a direct drive printer? Well, I think that direct drive, in particular, if you have a specific need for it, like printing flexible filaments, it is a terrific upgrade. You can make the settings adjustments you need to the printer, and you can print terrific flexible filament parts, just as an example. But if you are looking for direct drive as possibly a silver bullet to your printer problems, or direct drive, everyone tells me the best, so I should switch to direct drive. Well, that's definitely not the case. And as I showed you here, it's because Bowden does a really good job. There's a reason that there are so many printers that are Bowden setups, and it's not just because it's easier or cheaper or any of those things. It's because Bowden works, Bowden's light, Bowden can move quickly, and that's why people are choosing that as the default for so many printers. I truly believe that direct drive, in my personal opinion, is a bit overhyped as the best type of extrusion. So I wanted to put that out there because I think I'm going to get a lot of pushback for it in the comments, because I know a lot of people love it and think that it's the solution for everything. But I really do think that it's not going to be the solution for everyone. Like I said, for me, the test prints, particularly the Eiffel Towers, really didn't turn out the way I expected, and the other prints were on par except for the changes that I expected. So now onto the Micro Swiss kit specifically. So first of all, the quality. The quality of the kit is top notch. They spared no expense on the machining of the parts, on the quality of the metals. Everything is as it should be, and everything looks really, really nice. As you can see on my printer, it really has a great aesthetics to it, as well as being perfectly functional for what it's designed to do. Now, as far as the kit part of it, it comes with absolutely everything you'll need to install it in the box, so there's nothing to complain about. You don't need any extra parts. You don't need anything but possibly some of the tools that came with your printer to actually put this together. As far as the assembly is concerned, I did run into two things that you'll see if you stay through the end of the video. First of all, on the right-hand side, one of the notches is not really in the right place for a carriage with a BL touch on it. And what I mean by that is the BL touch will run into the little nib on the end of your belt in the setup that it's currently in, and you have to move it down a little bit. It didn't seem to cause any sort of mechanical problems, but I just didn't like that not running perfectly parallel to where it's supposed to be running. So I would like for them to move that out a little bit or something so it wouldn't run into the BL touch. The second thing I ran into was this whole assembly here, your entire wire harness, really needs its own place to attach to on this plate. I was able to kind of rig a place on there where it worked just fine. It seems to keep it out of the way. It's not ideal, so I really wish that they would have included some extra holes here to actually have a specific place to attach this to keep it out of the way. Again, I think mine will work fine. I used one of the holes that was there for some other purpose, and it seems to be doing just fine. As you can tell, I really like the kit, even though I'm not 100% sold on direct drive itself. So kudos to Micro Swiss for creating an excellent solution for those looking for an easy to install, really all-in-one kit to convert either their Ender 5, Ender 5 Plus, or even the Ender 3 kits if you want to go direct drive. And of course, I need to remember to mention the cost of this kit at time of filming. With the hot end, meaning the all-metal hot end, it is $99.75. If you want the extruder only without the all-metal hot end, that's still an option at $57.75, and those are in US dollars. So what do I think about the price of the kit? I think it's a really good price for all that you're getting. And keep in mind, their hot end kit is a more expensive hot end kit to begin with. So if you want to get it without the extra hot end, if you're not going to need all metal, just buy the extruder kit. That's still under $60 for some custom machine parts and everything you'll need in the box. So I really think still a good deal for what you're getting. So as I sign off here, I just want to remind you, if you want to see the complete installation of this kit, for informational purposes or so that you can follow along with your installation, please stay tuned until after my sign off, and I will go straight into the installation so that you can follow along. So full disclosure time real quick, MicroSwiss sent over this kit for review upon my request, and no additional money has changed hands for this review. The opinions expressed in this video were my own. So as always, thanks for watching my video, and thanks for making it all the way to the end of this one. If you haven't done it already, please hit the like button if you enjoyed this. If you didn't enjoy it, hit the dislike button. That's fine too. And as always, please leave comments if you have any questions, concerns, anything else that I didn't cover and you'd like me to cover. Please leave those down there below and I'll get to them. If you have found value in this video, I have PayPal and Patreon links down below that you can follow, and that helps produce these videos. It helps buy equipment and it helps buy products when I can't directly contact the company, or I just feel that it will be a better experience if I purchase those myself. Again, thanks for watching. I'm Chris, and this has been Kersey Fabrications. I'll see you next time. All right, so the first thing we're going to do is remove this shroud off the front of here. So that's going to be this screw here, and if you can get to it with whatever screwdriver or Allen wrench you have, it will be right back here between your shroud and your BL touch. There we go. Now as you can see, the BL touch and everything comes off here. And I'm just putting this down so that I don't lose it. And at this point, I want to just kind of let this hang off. You can go ahead and unsnip things if you want to. Guess we can do that just to be thorough and make sure everything is out of the way neatly. I can always put these back later. I'm going to go ahead and remove that one. That will loosen some of this up for me. And I can go ahead and remove this one. Again, I can put this back later. Actually, I don't need to snip this one. I can go ahead and just remove this spacer here. Go ahead and push down. And if it likes me, I'll be able to remove this now. If not, I'm actually going to have to remove the hot end to get this off, and that is pretty common actually. I'm going to actually take my spanner here, see if I can use that to push down. But it doesn't look like anything's going to come off. So actually, I can probably just remove this right here, and then that will come off. Basically what's going on is, since this is pushed all the way down into that hot end area, there's nothing to push here to actually get those barbs off of there and to loosen that up. So you actually have to loosen up the entire piece in order to get that out of there. Okay, so once you get it loose, this should pull out hopefully. If not, it could be stuck in the hot end. There we go. If you need to, if this still won't pull out, you may have to actually heat this up to get this to pull out. But mine did pull out. At this point, I think I should be able to pull down. Now that it's out, this will pull down and I can take that right off. We're going to use this hose again later. Again, on the direct drive, it's only going to be a path, so we don't have to worry about upgrading that to some nicer Bowden tube. There we go. Next up, we can go ahead and remove these screws holding on our hot end. And hold it so it doesn't fall. I'm going to carefully go ahead and remove these screws. Oh, my screwdriver wants to hang on to it. And this one. All right, at this point, we're actually almost done with this disassembly. The only thing we have to do here is we need to remove our heating cartridge and our thermistor very carefully from here so that we don't damage it. So I'm going to actually hold this whole unit in one piece so that I don't actually make a mistake. Let me get a Phillips head screwdriver. Let's go ahead and pull this off too, because we're going to have one thing we need to get out from there. So we're only going to have two screws that we need to remove in order to get this out. We have this Phillips head screw here to remove this thermistor, and we have this set screw here that we're going to remove our heat cartridge. So first thing, I'm actually going to remove this one first because this one's more delicate and I don't want that to just be loose. So we can use the Allen key that it came with, the hex key, whichever you want to call it, and that will loosen this up. All right. And then, before I pull that out, I'm going to go ahead and remove this Phillips screw as well. And this will come all the way out. There we go. Now this whole assembly should come off pretty easily as long as you're not too gunked up here. So we're done with this. This can be saved for a spare or just for another printer. So all of this is going to get reused. So we're going to set that aside. And let's go ahead, at this point, let's go ahead and remove the crap. Anyway, let's go ahead and remove this from the back. This is our extruder. Let's remove that from the back and we'll come back up here and I'll clean up that mess. Okay, back here on the back, this is a pretty easy disassembly. First thing we're going to do, let's go and remove the hose because we're actually done with that. That'll make that get out of the way for us. Let's go ahead and remove the spring and then that won't be popping off on us. There we go. That pulls off of there. And we can actually just screw this back in so that we don't lose it. Actually, that's not going to be enough out of the way, so it is actually going to have to come out. There we go. Let's remove the arm, because that is actually holding on one end of, or one corner of the stepper motor. There we go. Then we're going to go to a smaller diameter on our bit. Now let's go and remove the power from that stepper motor. We will be using that again later. Remove this screw. This screw. Now before you remove the last screw, ignore that. That's just the hot end, or the parts of the hot end. Before you remove this last one, keep in mind that this is holding on your stepper motor, so please don't just unscrew it. Otherwise, it's going to be a louder crash than what you've heard from me so far. There we go. See if that's off. Yep. Okay, and then we'll grab our stepper motor because we're going to need that again. There we go. Let's move back up because the next part of the disassembly is this. Oh, real quick before we put this down, let's go ahead and remove the gear that comes on this motor because the new kit comes with its own. And this is real quick. There are two screws on here that are going to come off very easily, and we can put that aside. Next up, we need to remove the carriage from our x-axis. And so first thing we're going to need to do over here is loosen up our belt. So to do that, this is pretty easy. We're just going to loosen up these two. And that will loosen up this piece here. There we go. You can see that loosens up that belt. Now, we are going to actually loosen up. I'm going to first take off our belts. Don't want to get ahead of myself. There's that off and that off. Now we can remove this bottom wheel to remove this carriage. So I have my hex key, my Allen wrench. I'm going to put it here on the back. And then we can use our spanner here on the front. Now both of these came with the printer, so you should have these. You can, of course, go an easier route and be using an actual socket set or something like that, but this will do the job. There we go. And there we go. We'll take that off. And now we need to remove these two wheels from the carriage as well because notice what happens to this printer. The longer you have it, it's just a mess. Anyway, so we are going to remove these two wheels because we're also going to need these for the new kit, but we won't need the piece of metal holding it all together. There we go. There's one wheel off. Now, according to the instructions, the only thing we're going to need to save from the stuff that we took off, as I mentioned, we're going to need to save the stepper motor. We will need to save all three of the wheels, which I'm going to clean off nicely first. And we are going to need to save the eccentric nut for reinstallation. Now, I think we're ready to start the new install. All right, so back down to the table for a minute while we assemble the wheels onto the new carriage. So we've got our wheels. These are screws that it came with. So we're going to put those in here. Now these are the ones with the nylon on the screw. And we're going to insert those in the top two. And we'll take the other one. We're going to just get these started. And then we can take our hex key and tighten this down. And we're going to tighten it down until it is tight enough to where it's not moving, but that the wheel still moves freely. And hopefully that means we can tighten it all the way down. Again, I'm just going to keep moving the wheel as I'm tightening this, and it does tighten all the way down. Wheel still moves freely. Let's do the same on the other one. Okay, tighten that one down. Wheel still moves freely, just as we would hope. Now for the last one, we have, again, this screw came with the kit. We're going to take the wheel, put that on the screw first. Then we're going to take the eccentric nut. Notice it is not symmetrical. There is a longer end and a shorter end. Shorter end is going to go to the screw. Now this is ready to be installed into the bottom one, but to do that we actually have to go back up top on the printer. All right, so here we are at the top of the printer again. We will take our new assembled carriage. We're going to just set that in the groove just like it was before. We have our bottom wheel assembly with our eccentric nut. That will fit through this hole and again into that bottom groove. Now we have a washer that it comes with, and we have a nylon nut which also comes with the kit. We will then tighten all this down. All right, once that is all tightened in place, it should move fairly well. Now what we want to see is the right tightness to keep this from wobbling and to make sure that the wheels move as they're supposed to. So if I move the bottom wheel with my finger, you notice it moves the whole carriage, and the top wheels are both spinning. I can do the same thing with the top ones. And so I really don't need to mess with my eccentric nut here, but if it was too tight or too loose, you can mess with your eccentric nut and get it just the way you want it. Again, if I go tighter, you can actually feel that it's too tight. And I don't think there seems to be really a too loose on this one. So luckily that kind of went where it was supposed to. So I'm going to leave this alone and let's go to the next step. So next up, let's go ahead and reattach our belts. And the other side. Okay, so the belts are in their slots. Now we can come back over here where we loosen this. We're going to manually tighten this up with our hands, and that's about all this printer offers in terms of tightening. We can line these up to where they're centered on our 2020 extrusion. And then we're going to just tighten these down. And we'll see if our belt is nice and tight. And that is pretty good. Now I just like to go for something that's a little strummable, but nothing that's too tight, because you're really not going to get anything better out of a too tight belt. So I'm going to loosen this up one more time so that I can make it just a little bit tighter, and then I think I'll be happy with this new installation. So for the default installation here, I'm actually going to use the stepper motor this came with. Now this is kind of heavy, and I'm hoping we can go with a lighter, smaller pancake stepper so that we can get some weight off this carriage. But we're going to try this one as default just to make sure everything works correctly. This is a pretty easy installation. We're going to put our connector facing up. Then this did come with some countersunk M3 screws, which we're going to actually attach our motor down with. We're going to go with one of the top ones first. I find that's the best way to secure it so it doesn't fall. Don't tighten that down all the way until we get all three of these in. And since these are countersunk, they should keep the motor exactly where we want it once all of them are in. Okay, we're going to tighten down the three that we've installed. There we go. So next we have the lever that's going to actually hold our filament in place, and they have what's called the precision shoulder screw that's going to go in right here and clamp this down. So that's going to go in here, and this right here. Oh, and I want to show you this real quick. These are the really nice teeth that they were talking about on the package. This is a very nice gear that they have here. So that's on this side. The other one will be actually on the motor itself. We can tighten this down. And that moves freely, which is really nice. Now we can install the second half of our gear. Now again, extremely nice machined gear here. Again, I don't know how they make these, but very nice piece of work. And hardened steel, I believe, on this. We're actually going to make sure that the flat part of this motor right here is somewhere that we can get to it with our small Allen wrench, which I have right here. And so we're going to line up the screw. This is the set screw. We're going to line that up with the flat part. Go ahead and get that on. As you can see, the flat end is going to go towards the end of the shaft. Again, line that up on the flat side. We're going to put this together right here. And what we're going to do is we're going to take a piece of filament and make sure that we're all lined up here. And that should fit right there between those two pieces. And if we hold this tight, we'll make sure that we tighten that down right in our filament path. So I'm going to now tighten this down right here on the, again, on the flat side of the motor shaft. I'm going to tighten that down really good. And now if I move the filament, you'll see everything moves real clean, just the way it should. Next up, we're actually going to put the pin in that's going to hold the lever in place. So we have the screw part here. We have a spring that's going to go onto the screw. That's going to go through this side. And then we can tighten this down with this end. That goes on right here. They say until it's at the end right here of this screw, which you can't see the end of it, but it's going to be flush right there. And they said that that is a good starting point for PLA. They say to loosen it up a little bit for the flexibles. That's all in the instructions, but that does look pretty good. Again, this is a geared extruder in terms of both of these sides are geared together, and then there are gears, teeth on the inside of both of them that are going to grab our filament. So this is a really, really nice extruder that's going to clamp onto our filament and not let go, unlike some other ones I've seen lately. All right, so let's assemble our hot end now. First of all, we're going to pull out our heatsink. All right, so let's just go and pull this off of here. Next of all, we're going to need our heat block. And so we're going to actually attach this onto the top right here. That's just going to screw in there. And then we use the wrench that it came with, the spanner. We're going to tighten that up. It doesn't need a whole lot, just enough to make it tight. And we're going to get our nozzle. The nozzle then goes on the bottom here. We're going to again tighten that up, and we can tighten this again once we heat it up for the first time, make sure it's in place. Next up, we're going to mate the heat assembly here, the heat block, to the heat sink. Let's find our set screw. It should be in this bag. It does come with an extra one, which is terrific because these are really small. Then the set screw, we can go ahead and put it on the end of our Allen wrench. And we're going to make sure that this is good and tight. So I'm holding it in place, and then we're just going to screw that in here. Again, make sure it stays relatively square. You can even put it down on the counter as you tighten it. There we go, that whole assembly is in place. Now we're going to need a few other things out of this bag for our next part of the assembly. We're going to need one of the spacers. We'll need the two screws that are going to attach to the plate that we just installed. Then we're going to need this one screw that's going to attach the thermistor into our unit here. So let's head back over to the top and we will install this. All right, so let's install the heatsink onto the mounting plate. First of all, we need to install the PTFE tube, which they provided. And what we're going to do is just stick that in here. Notice it has a beveled top here that's going to match up right here so that we don't run into a problem with filament escaping through that area. And then we can attach our little spacer. I'm going to push down on that while installing the spacer. There we go. And move that forward, side, it doesn't really matter. And then we're going to insert this into here. Again, making sure everything lines up, it should. And that pushes right up against the gears right here, which is what we want to see so that we, again, don't run into a spacing issue where we have filament escaping through that little space. Now we use the screws that it came with, the ones that are countersunk, and those are going to go right in there. I'm going to put them both in so that we can tighten them down, and then we can tighten all that down. And since these are countersunk, they're actually going to naturally want to fall into the place that they're supposed to be, which is the nice part about these countersunk screws. Alright, so now that's good and tight. PTFE tube runs right where it's supposed to. I want to make sure that this still runs smoothly, so I've got my filament. And again, this should run back into here. Pull this way. A little tough to get it down in there, but not too bad. And it does move freely at that point. The PTFE tube is not rubbing or getting in the way. So that's a good sign. Okay, let's grab our hot end assembly parts from before. And I dropped something else. This is just getting par for the course. And we're going to push all this over here. Now we're just going to need our heater cartridge and our thermistor. Heater cartridge goes right in here. Thermistor goes in the side just as before. Hopefully this will stay up here without falling on me, but I won't count on it. So let me go and grab a small Allen wrench from before. Going to tighten these up. Again, I'm making sure when I tighten these up that all this wiring and everything is going up, maybe up and back a little bit. And I can tighten this up, which is going to hold that heater cartridge in place. There are just two screws underneath here. You can see the tops of them here. And then for the thermistor, we're going to take the screw onto the side. It goes into the bottom hole. I don't have a picture of this. Maybe I'll post one up here on the screen. And that's just going to tighten down right there to tighten everything down. I'm going to make sure that that thermistor is actually in the hole really well as being clamped by that screw well. Oh, there we go. Almost dropped the screwdriver. I'm clumsy today. That's all right. Okay. So that is attached. Don't over tighten that, you'll crush the wire. We don't want that. So the next thing that the instructions tell me to do, they want me to go ahead and make sure that this nozzle is fully seated so that we don't have a problem. So I am going to cut on the printer now and heat this nozzle up to 220, and then we're going to tighten it down to make sure that it is ready to go. All right, we're all heated up here. I'm going to use a wrench to hold the heat block. I'm going to actually use a socket to actually tighten up on the nozzle. This is a 7mm socket, and now that's tight. And then while we have it heated up as well, we're going to go ahead and tighten in these screws. Be very careful when you're doing this because this is very hot. This is at 220 degrees, and if you touch it, it will burn you. This is your warning. And there we go. So now we've tightened everything down hot. Go ahead and tighten down this one too. So now we can cool it back down and go to our fan installation. All right, let's get the fan installed as well as the BL Touch. We're going to pull this over here. Now you notice that I have this centered right on the rail just as it should be. Now when I go to install the BL Touch kind of gets in the way of where this is located. And what that means is in order to fit it to the screw holes, I'm actually going to have to push that down a bit, and now it is no longer even with that rail the way it should be. I don't know what the effects will be on our print. It actually could be negligible. It could actually be nothing because, of course, we're not actually rubbing on anything here because it's pulling it away. But it's just something to note that it's not perfect. For them to have fixed that, they would have had to run this out just a little bit further on their model. So just important to note. So here, going to pull up on this a little bit. I want the fan to come out this way, but then those hot end connections are going to have to be up in this area. So I'm going to do this, put this behind it again, and then that should all hopefully fit together without any problems. Okay, I'm going to reinstall with the screws that we originally took off of here. It doesn't come with any new ones for this step. I'm going to install the top one first because the other one is more difficult to get to. I won't tighten this one down until I get the other one in. This one's pretty tight in this area, so be very careful not to drop the screw, which means I probably will. Let's see if I can get it, find the inside hole there. Okay, tighten this one down now. And I can tighten this one down. And all of that is reinstalled again. Now, this is a little out of order from the instructions, but I honestly don't want to move the camera back around. So I would recommend cutting off your original tubing because there's going to be gunk inside of it. It's going to be a little bit worn out from printing. And all of this would have been down in this area anyway, so it doesn't matter if we cut some off. We're not going to run out of length. So I'm going to cut it. If you'll notice, there's an indentation right here. Hopefully you can see that all right. There's an indentation right here from where the old coupler was, and I'm going to cut it right above that. I'm using my level cutters here, and I'm going to cut it right above that point. And now I have a good clean end on it. Then I'm going to put this in here. Make sure it's a bit straighter than that. This will go in here. I will push it as far as it goes. And then it comes with a little connector that will push in here and hold that in place so that it doesn't come undone. And that holds it actually really tight, really nice. It's a good solution. Now, while I'm here also, I can go ahead and hook up the electrical end to our motor. And now this extension cable is going to go to where our other cable ends. So there we go. I think that's it for this area. Obviously, you could do a little cable management here, but it's not too bad at all. I have my cable going off this way, and then I have my Bowden tube going back this way, so I don't think there's any extra cabling here, and hopefully this won't put too much stress on this wire. If it does, we're going to have to find a way to maybe use these holes or something. It's got some holes over here that we could use to tie that down. But looks pretty good. Let's go back to the back of the machine where we're going to finish our installation. Okay, for the last bit of installation here, we have this nice 3D printed part that they have that we're going to install right here that hopefully will line up the filament path, at least close enough to go into our filament sensor here. And they've included some M3 screws that are going to go right in here and in here. And then some nuts that will go on the back to hold it in place, because normally the motor would be back here doing the holding. So we don't have the motor to screw this into. So we're going to put our nuts on the back. And they will provide you this model if you want to print it in another color, or if there's a problem with yours and you've broken it or something like that and you just need to reprint it. So let them know if you need that. And I'm going to just tighten this down. I'm going to hold on to the back here. And just tighten it down. Doesn't need to be too tight, obviously. It's not actually doing anything except holding the other end of that tube. So that's good and tight. Oh, and I forgot to do this a minute ago. It does come with the sock that you need, so make sure you put the sock back on there. The open side goes towards the wiring. There we go, snapped into place. Now that's there. Okay, so now we're going to take the other end of this Bowden tube, and it's got another little clamp on here, spacer, and we're going to pull that off. I'm going to stick this in here. Just needs to be snug, and then we can put that on there. So now this will not come out. Let's go and take a look. I'm curious to check that filament path, make sure that there's not going to be a problem. So if we go through our filament sensor, there's a bit of a turn here. I'm wondering if this is, well, It works. It's not ideal. I think we need a slight redesign to this model to just push it over to my left a little bit, your right, so that it lines up better. That's not the best fit. I'm guessing that this is more for the regular Ender 5 than the Ender 5 Plus. I think this will work. Doesn't seem to really be hindering it, but obviously not the best solution if it's not a straight path. All right, so now we can look at the rest of the wiring. So we do have our extension cable right here, which we did run before. We're going to go ahead and unhook all of that. I'm going to run this down this way. And see, this is the wire that came with the printer. This is the one that used to go to the motor that was right here. And we're just going to mate those together. No problem at all. Now what I want to do is I'm going to take this around here. This will give me a really nice place to put on one of the provided cable ties so that, or I actually may need a bigger cable tie. What I want to do basically is, this is as far as this plug goes anyway, so if I put it right here and cable tie that down, let me get a longer cable tie. I'm going to cable tie this right here with this end facing up. There we go. Now that won't come undone. And now this can be run up here along with our hose. And I think that they meant for it to be done kind of like this, which actually works really well also. I'm going to run this right here. It's got spots in it to actually attach these cable ties, so those go right through. I don't think the instructions really spell this out, so I'm just kind of looking at the design and seeing what makes sense to me. So there we go. That's a good start to that cable. Snip, snip. And that looks really nice. Now let's look a little bit more at the cable management to make sure I'm happy with that before we start moving around these cables too much. So looking at cable management, first thing I see is this is kind of loose and it hangs down a bit. I think ideally what I'd want to do is actually have one more hole here that we could use to actually attach this where it would not move very much. So maybe down the line I will come in here and simply drill another hole so that we can attach that wire right here. Given that we can't do that, I'm either going to have to just leave it loose, or I can actually try to put a cable tie through here and maybe just, you know, kind of loosely hold it in place just to limit the movement a bit. So I'm just going to do that. Again, that doesn't do a whole lot. It doesn't do as much as I want, but it does a little something, I hope. Next up, of course, we've got our Bowden tube here, which isn't technically a Bowden tube anymore, but it is a routing for our filament. And we have the wire here now that goes all the way back to where our stepper motor used to be. And what we're going to need to do is just make sure that this is connected to each other, because that wire, of course, will hang down while the tube itself will actually be fairly firm and stay in that arch that we want. So go ahead and put cable ties along here so that we are not hanging that wire down into our prints. And other than that, I think that's it for the cable management. Now at this point, we are going to need to calibrate this new extruder. And in order to do that, I don't actually have a guide up yet, but if I do get a guide up, I will put it up here on the screen, or up here on the screen, wherever it is, and I will give you that information. But anyway, I will link in the description to a guide on how to calibrate the extruder. Just for reference, they say to start the calibration here at 130 steps per millimeter, so that's what I'm going to start with, and then work my calibration from there. It's also important to keep in mind, on the Ender 5 Plus, we do not have the ability to calibrate the steps per millimeter on the display, at least not with the default display that comes on the printer. And what that means is that you're going to have to do this efficiently, you're going to have to hook this up to a computer through the USB port, which I do have a video on, which I will link here, on how to connect that up to the serial port. Again, this is a video on this part. I'm not going to spend a whole lot of time on calibration itself, so check that out. And then once I have it all calibrated here, we can start taking a look at our test prints. Also, don't forget that you're going to have to reset your Z offset, because obviously the nozzle has changed location. So make sure you reset your Z offset as well.